Can you guys hear me in the back pretty well? Cool. So today we're going to be talking about getting R into your applications, and it's going to be mostly about your web applications. Is there anybody here that uses R on a daily basis? Okay, so I am going to admit that I know very little about R, but what I'm seeing happening, is this trend, and I think it's important that we start thinking about how we can integrate R into our apps. So please don't heckle me. So my name's Tony Milne. I am the Director of Applications Development at WP Glimcher. We own about 120 malls across the U.S., including this mall over here, Polaris. I am I'm the treasurer for the Dog Food Conference. It's October 5th and 6th this year, so you've probably heard that a few times. We've been to a couple different talks today, and encourage you to go out. It's a great conference. I've been a little bit more about myself. I've been living in Columbus for about 15, going on 16 years, husband and father of two young kids. They're great. Big fan of the Buckeyes. I don't know how you can live in Columbus and kind of not be. So, all right, let's get into it. So what is R? So I started to put together kind of some bullets to talk about what is R, so we can, as developers, you can understand more about what is R, what it really is about. And as I compiled information and stuff, I ran across this video from Revolution Analytics, and they really do a much better job at explaining
What's behind the statistics, the analytics, and the visualizations that today's brightest data scientists and business leaders rely on to make powerful decisions? You may not always see it, but it's there. It's called R, open source R, the statistical programming language that data experts the world over use for everything from mapping broad social and marketing trends online to developing the financial and climate models that help drive our economies and communities. But what exactly is R? And where did R start? Well, originally, R started here, with two professors who wanted a better statistical platform for their students. So they created one, modeled after the statistical language S. They, along with many others, kept working on and using R, creating new tools for R, and finding new applications for R every day. Thanks to this worldwide community effort, R kept growing, with thousands of user-created libraries built to enhance R functionality and crowdsourced quality validation and support from the most recognized industry leaders in every field that uses R. Which is great, because R is the best at what it does, letting experts quickly and easily interpret, interact with, and visualize data. Join the rapidly growing community of R users worldwide and see how open source R continues to shape the future of statistical analysis and data science.
Okay. So a few things to kind of recap on that video too that extends a few other pieces of information. R is both a language and a runtime, so you write an R script, but it also has the runtime to build graphics, and it's your debugger, and of course it has all of those packages available to you for all kinds of statistical functions and other types of functions. And as you build your own functions, you can publish them out as well. It was created in '97, and they mentioned it was based on S, also kind of based on another statistical language called Scheme, and incorporates those four languages, R, C, C++, and Fortran. And I think that I saw an article that was about 2 years ago, and it said how much R code is in R, and it was somewhere around 25%, so kind of an interesting number. So when data scientists or analysts or anybody else use R, really, kind of at the highest level, they're pulling data from a source, a database in this case, loading that into memory and analyzing the data. So there's some drawbacks with doing that. One is that it's really kind of a single-threaded piece then, and everything is flowing through that user's machine and the constructs of that, and there's some issues with just running through one person's machine. including memory and processor and things like that. So if we're loading a big data set into there, I mean, I don't mean big data, I mean like a large data set, and we're going to hit some issues. It's not very scalable at that point. So some folks at Revolution Analytics, this company that did that video, they kind of put a framework together that allows you to interact with R in a way that is kind of what we see with some of the big data platforms like Teradata or Hadoop or anything, where it more or less takes these multiple, the script and kind of spreads it out and runs it multi-thread and brings it back that way. So that kind of worked out really well. And it worked out so well that Microsoft decided to buy the company. And I think that happened around March of last year. It was early last year anyhow. So Microsoft bought Revolution Analytics and decided, well, what are we going to do with it? So they said, well, let's include that as an extension of SQL Server 2016. So now in SQL Server 2016, you can actually, through SQL Server, interact with R directly. So now all these R scripts and those few folks there, all the things that you guys have built, we can leverage that without having to know how to directly interact with R. We can take your scripts and kind of combine them together into something that we understand better, maybe using T-SQL. So when you install SQL Server, and I'll talk a little bit about this in a minute, there's kind of two pieces for OpenR. For Revolution R, their package, and one's an open source piece, which is fully supported, so no issues there. And then there's the enterprise piece as well. It's a little bit more robust, and both versions, they're fully tested and fully supported. So whether you go with open or the enterprise version, you're kind of covered there. I talked about we can leverage T-SQL, kind of something that's more familiar and something that's a skill that's more broadly known, and leverage those R scripts inside of SQL. And one of the interesting things too, when I was looking at this, is that inside of R, there's its own machine learning. So when we talk about ML, we hear all different things, and probably the most thing that we hear from the Microsoft side, of course, is Azure ML. But that seems like this thing that's difficult to get into, where we have to go to the Azure platform to use it, and maybe that's not right for us. And maybe we have some scripts that are already good to go, some models that we've already built, and we can leverage that directly from SQL Server. So by doing this, what we're really doing is we're taking and sitting a platform in front of R, and now we've exposed R to all kinds of people, from DBAs to other data scientists as well, that can connect right into SQL Server and start working, developers and analysts, and a whole world of different people. So in SQL Server, there's kind of two components now in SQL Server 2016. One's R services and one's the enhanced R packages. And the R services is really what creates your conduit between SQL Server and R. And that's what we'll be looking at here a bit more. The enhanced packages really allow you to, from your local machine, kind of build these same types of scripts without having to deploy to any server, a test server or anything like that. So it allows you to dev locally and use the platform, just a scaled down piece of it, of course. When you install SQL Server, there's two new options here that kind of highlighted for you there. One's the R services and one's the R server itself that we talked about. When you select those, you'll get this accept screen that it was going to download OpenR at that time and install it on that machine. So it's kind of something a little bit different than what we're used to when we install SQL Server, so I just kind of wanted to point it out. So one of the pieces that we're going to go through, as you're probably seeing it heavily, is using the SQL Server, the R services inside of SQL Server. So this graphic here from Microsoft really explains how we can interact with SQL Server and R. And the top version is really, some of the demos I'm going to get into is really what we're going to be looking at a lot. So it's calling a stored procedure running the R scripts, and bringing that back. And I'm gonna do some demos later that builds up to actually doing that. And then the second way is really from your own workstation and doing those same types of calls using the SQL Server database for that. So before we get into that, because there are a couple of people that understand R and use R on a frequent basis, but for myself and the rest of us, I just want to show you some syntax so when we get into the demos, you're a little bit more familiar. So assignments and some traditional code will say x equals 1, so 1 we're putting into x. In R, we just left arrow and tack, and that assigns the variable x, or 1 into the variable x, right? You don't really even have to declare it necessarily. You just say this variable and roll with it. Arrays, more traditionally, this is how we would do it. We would declare the type and the name and fill that with some data, in this case 3 names. In R, it's a little bit shorter. Again, we don't have to tell it the type necessarily, so we've got this variable called names, and this function C that's telling it that we're going to build an array of these elements, or these items in the elements, and it's really all those, the only kind of caveat there is all those data types have to be the same. We can also tell it to build out an array of numbers. So in this case, we're telling it between 12 and 20. So that's going to be 12, 13, 14, 15, 16, 17, 18, 19, 20, all 9 numbers there. Loops, I think we understand how to build those. In R, it's a little bit different. Same concept of here's an array with 20, 17, 4, and 22. We assign that, and then we can use that array and just, in this case, I wanted to multiply 0.15 by every one of those items and get that result back. And I'll return back because of, well, I'm missing the syntax here for how you return that back, but it'll return that back kind of in a row-based form for you. Okay, let's get into a demo. I'm gonna have to switch back and forth here. I can't even read that. Can you guys? Are we good now? Is that better? Okay. So what I have here is just a simple database, and I'm going to drop a table into that database and just populate it with a couple pieces of data, 1, 10, and 100. And we're going to leverage this table throughout the rest of this part of the demo. So let me get a little bit more room for us here. Now we have this sort procedure called SP-execute external script, and we will pass it what language type we're using. In this case, it will be our input set and our output set. So the output data set is what we're going to actually get back. So that's kind of an important thing. You'll see that again and again. Our input data set is going to be the data from the table. So all I'm going to illustrate here, and then we're just using result sets and give it a new aliased name to show that you can change the column name from column 1 to new column name. And this isn't sophisticated, but this is just going to show we're going to take data from SQL Server, send it to R, and bring it back. And this is not reflective of how fast it should be. My VM is really small because it's running on my Surface. Okay, so voila, we have data going into R and coming back. It's magic. Okay, another piece, and I'm going to kind of build on top of this same theme here. This is really just to show that our data inputs, if we want to give those different variable assignment names, we can do that. And so it's fairly similar to what we were looking at here before, right? Except now we're just changing our input and our output set name and bringing that back. oops, 12. So well, instead of the whole data set, we just passed in a hard-coded value of 12. It is case sensitive, so you've got to be a little careful with that. If we drop that to lowercase, it's going to give us a nasty error here that says it doesn't know what this lowercase SQL n variable is. So we move on, and now, I showed you that array before and how we build an array. We're going to take the array and assign it to a variable and bring it back. And in this syntax here, what we're going to do is bring it back row-based. This isn't actually really needed, but so we took this array and we just said pivot it and bring it back row-based. So this is very nice because if traditionally I had, well, in this case, let's just say if they were spread out as 4 columns and I were selecting that from the database and I wanted to pivot, I have to write a fair amount of code to pivot that into one column, right? And then vice versa, which we'll show in a little bit, to pivot it from row-based to column-based. I have to write a good bit of code, and it's really kind of hard-coded at that point to the number of columns and things like that, and we can get around some of that. It's a really nice piece there. So this here is very similar to what we were just looking at, except now we're going to be column-based. Same data, just column-based now, because we're not using this. If we had put that AS there, is what we saw before. Now I can get a little fancier with this. And basically, instead of only passing in one line, I can tell it, well, here's this array, and here's this other array. So kind of on the shoulders of these two words, I want to apply this array, and it'll put it in that order. So as you see, we have, it's kind of, can you see that all right? Trust me anyhow, if you can't. So, yeah, so now we have the data, and as I said, on the shoulders of those two words, my little, we put hello and world and later world. So now we can get a little bit fancier, and this is where R starts to shine for us, and I wanted to create a normal distribution here of 20 numbers that have an average of 100. So this is going to take and generate 20 numbers where that average is 100, and it's a normal distribution, right? And let's bring that back. So here are the 20 numbers. Clear? Well, so if we average those numbers out, we should get right at 100. It's actually just a little bit off, but it's pretty darn close. And all I'm really trying to illustrate here at this point is just that, it's beyond sending data in and getting data back. We can actually leverage the full power of R right through SQL Server here. So now what we're going to do is we're going to take an array, and I told you we can just say, well, give me an array back of 1 to 6. And that'll give us 1, 2, 3, 4, 5, 6, right? And cross that to our data set. And our data set, again, was what? 1, 10, 100, right? So now let's get that back. Great. So now we have 1 through 6 on the left and 1, 10, 100, our same 3 rows of data applied across that. And we have to be a little careful because if we can break this if it doesn't quite line up. Okay? I promise we're just building up so we get an understanding of what we're doing when we get into the actual web code here. So the next piece that I want to show is that we take this data of 1, 10, 100, and we can cross-multiply that across 12, 13, 14, and 15. So it'll be 12, 13, 14, 15 multiplied by 1, 10, 100. And this is what we get back, that exact data set. So very little code to create this kind of mathematical computation against 2 data sets, right? And let's take that a little bit further and say, well, I want to cross-multiply this array and then sum them together. We'd have to write a decent bit of code to do that in SQL, or we can do it here in our script, and it comes back pretty quick as 1542. This is our key right here. If our result sets are undefined, we can just get back a message that's just a script of the message, really. So it's telling us that in column 1, the column name was 1, it's an integer type, and here were your data fields that you sent in, and that's what you're bringing back. When that video went through and scrolled through all these libraries and packages that are available, to leverage those packages, you have to use them just like if we'd use any other DLL in C# or anything like that. And so we're going to load the utilities library. There's a function in there to get what the memory is and give that back. So this is actually going to hit against the server and tell us how much memory we don't have, which is about 4 gigs there. And just to show that this is the same script, here's the R console, and if I paste that same data, or that same script in here, and I say, give me the output data set, I get that same exact value back. Oops. Okay. Now, if we take this, all we've done is just execute this built-in store procedure for us, and we can take that same code and drop it into a store procedure and get this data back. So now, this is where we're building up to how do we actually invoke this from our applications and in the way that we understand how to do that. So, let me bring up the code for this. So here's a procedure. The parameters coming in are, this is our array and how big, what numbers we want in between 12 through 15 are the defaults. And that's all it's going to do here. It's going to build up a string that just says this, for instance, or whatever we put in there. And then multiply that against the data set that we've been using. Okay? So what I showed you before, where we did it with just in calling the sort procedure direct, or the procedure directly, we're going to do that within a sort procedure right here. So if I give it the defaults, oh, come on. Same data we saw, we take that data set or that array of 12 through 15 and multiply it across our data set. Or if I pass in variables, this will be 7 through 10, doing the same thing. Okay? Oh my gosh. I'm trying to hit the minimize, and it thinks I'm hitting the... What's that? Okay. Windows P and see, I can't get up here to this guy. You've got to be kidding me. A few issues there, apparently. Sorry, guys. All right. Why will it not? I did it. Maybe. And it did it within. Damn the bad luck. Well, forget it. We'll just get right into the other demos, and there were a few more slides, but it's apparently having an issue. if I do this, that'll probably fix that real quick. Oh my gosh. Okay, well, I'm a liar apparently. So I tell you what, let's just go ahead and get into some of the other demos that I promised, and if I can get back to the slides, and I'll talk about the slides, but or I'll show you the slides. But the next thing I want to get into, though, before I do get to demos, is just explain a few things. So there's a couple of different ways now that we can interact with R through our web apps. One is we can use Azure ML and leverage there. We can use Shiny, which is a widely available application development framework for you. You don't really have to know any web code or anything like that, so really no web development skills are necessary there. And then there's our old standby, which is Visual Studio for a lot of us. Inside of Azure ML, you can actually create your own R scripts in Azure ML. And those scripts you can take and whatever those R scripts that you're used to using, put those into R, build your models, and roll with Azure ML if that's what you want to use. Once you create a process in Azure ML, you can publish that as a web service, and then now it's just a RESTful web service that you would call from your application that you would normally do. So you would invoke the web service and get whatever it brings back to you. The next thing we can use is this thing called Shiny, and Shiny is produced by the same people that created RStudio, which is a nice IDE for developing in R. Shiny is free and open to you. You can use it, download it, and install it. And I'll show you a little bit about. I'll show you a little bit of Shiny here in a bit. Once you've finished your application, you can publish it to their platform. So they're a complete software as a service. Take your application or your widgets or whatever and publish it up to shinyapps.io. And then as I talked about, we of course have Visual Studio as well. Okay, this thing really messed with my mouse when I did that. I'm sorry, folks. Okay. Well, I'll have to do this all from the keyboard here. Okay. So what I want to work with is this this data set from, it's kind of a popular data set. It's New York City taxi fares and their trips. So here we have a bunch of trips, and we have their medallion and a few other things too, including how many passengers were there, the time it took for the trip, and out to the right there's another variable or another column called tipped. Let me just put this out here since I'm having an issue with the mouse. So tipped. So this is just a binary yes or no. Was there a tip provided by the passengers for this trip? And that's what we really want to look at here. So we're going to create a model in R and see if we can predict if a particular trip or set of trips will be tipped or not. And I need a tip on how to get this mouse working, actually. I think so. Let me, if you guys don't mind, I'm sorry. Let me try this again here. I'm really sorry, folks. I don't want to reboot it because I didn't save anything, so. Here we go. Oh, that would have been dangerous. So let me go back and go through everything I just talked about real quick. Okay, now we did that. No. That can't be good. Okay, are we good to go? Sorry about that, folks. I think that was painful for you. Should have tried being me. What's that? That's right. Okay, so what are we talking about again? Okay, all right. So let's talk about some of this data that we were trying to talk about before. So while, oh, for Pete's sake, while that's building, we're going to look at what this code's actually doing. Or we think we are. My mouse is wigging out. Gracious. Okay. So here's this data that I was showing you before. So it's going to take a table sample at 70% every 98,000 records, send that to R, and tell R to train a model based upon a few variables: passenger count, trip distance, time in seconds, and the fare. And we're going to pay attention to what that tipped output was. Once that comes back from R, we'll put it into this table called NYC taxi models, and we'll use that. So it's just a one-column table that has a var binary max on it. Okay, so the model has been built, and we can see really easily that there's the model and what it's doing, right? No. So the next thing that we're going to do, since we trained it on, I kind of quickly said that, since we trained the model based upon 70% of the data, we really want to look at the other 30% and see how the model is working against that 30%. That's what we would want to do to test the model. And that's what this query is doing. It's really just joining the data set that we would have been using against the data set that we didn't use. And then that'll send it into this sort procedure called predict tip 2. So then, if we look at predict tip 2, what's that doing? Well, that's just getting our model. So there's our model. takes the model, it takes the code or the data set that we're bringing in, runs it against the model, and gives us back our score, which is this last one here, as well as the other data points that we fed into it. So let's see what the results of that actually look like. This was taking 10 to 20 seconds on my machine before. It took 11 here. Okay, so we have this data, and I understand it's maybe a little difficult to see. And we have a 0 to 1 chance of getting a tip. Now, if you notice, this score over here is what we're looking at for what the likelihood of getting that tip is. Okay? Now, that all looks very close, but it's because, I think it's because the data really is so close in nature. So I would think that if we look at this, these two, if you're looking at the precision-wise, are fairly far apart, right? And it looks like the distance was a bit more on the first one than the second one, and we got there a lot faster. So the likelihood of the tip was apparently a bit higher. Now we can take that similar type of code and run that individually against the model. So we took the data set, and maybe we feel good about the model, and the model's been well trained, and we feel that we can use that model as our basis for predicting these tips. And now, if we were running something where we wanted to take just one set of data for a particular trip, and that's what these lines are representing as individual trips, and say, well, what's the likelihood of getting a tip for that data, based on that data? In this case, it's 0.500661. Now, if I increase the fare amount and I increase, go over here, the number of passengers, that's what these inputs are, the number of passengers, I want to see how those all compare. And what we see is actually as the number of passengers and the fare amount went up, the scoring went down. And that's likely just because this data set really is only showing us one passenger across the whole set, and the fare amount doesn't vary too much. So it's kind of a weird representation, I think, of the answers here, but this is why you would continually train different models and continue to play with that, right? Okay. So now that we have looked at that data, we're going to kind of leverage that in something that might be more familiar to most people, and that's MVC. So also, don't laugh at me about my coding skills here either, because I'm actually more of a database guy. I don't know if you noticed through the script that I used mostly SQL Server as my demo basis, so let's not make fun of me here either. So we just are going to use MVC. Drop this. Real simple view. Here's our controller. It's just going to have a default of 7. We go to our Git. I was pretty awesome here in my skills and put the code right there in our model, so right on with that. This is doing the same code, the same SQL script that we were looking at here before. We were comparing our how our model turned out. So it's the same thing, except instead of this top in number here, we can now pass it any number we want. And so that's really what we're going to do here, and then get back our predictions. So this runs really slow on my machine right now. So when we get it, so I kind of pre-ran it for you here. Stop that. Okay. It's the same data now, we've pulled back the first 7 records and showing our scores against the first 7 records. Now, if I extend that out and pass 25 in, what does that look like? Now we can see the same data coming back. Let me kind of hide this guy. And this is 100. So if I pass 100 in, let's see the 100 records. Okay? And so now what we've done is we've taken a data set, we've trained it against a model in R, so now we've used R's ML to create a model against predicting just in a chance of getting a tip or not. And then we've taken data set and applied that and shown that back. So now we've kind of created a way to provide intelligence to people with a platform that we're pretty most of us are pretty familiar with as well. So let's talk about a platform that maybe we're not familiar with, and that is RStudio. My computer's like, just kidding, you're not opening that. So what I want to talk about first is that in Visual Studio, when we created this application, lots of code, lots of pieces, and lots of parts that we had to kind of put together. In RStudio, when you first run it, this is the first thing, the first kind of example that it gives you to run Shiny. So if you've installed Shiny, it will automatically have that all available for you here. Let me show you a few components of what this really looks like. I'll zoom in a little bit. Okay, so the first thing we're doing is we're loading a library called Shiny. I told you we downloaded Shiny before, and now it's there. Shiny has 2 components, so it's a little bit like Ajax, really. So you have the UI side and you have the server side, and we're going to pass into the UI some code, and I'll explain a few things here, and into the server side some code, and then we'll call this function Shiny app to actually run the application. All we're really doing here, it's kind of jumping around, is creating a really, really simple application to show a histogram and a controller that will allow you to change that histogram. It's probably one of their most, their biggest example. Okay, so here's Shiny. And here, this is for Old Faithful Geyser data. And it's just a simple histogram, the number of bins, the number of columns really here. We can control that right here. No other work that we had to do. So when I talked about Shiny before in the slide that you didn't see and then saw later, it's really, you don't need to understand how to build a web application because we just did. And I can prove that even further. Sure, why not? We've blown everything else up here today. I don't want to. Hey, check it out. It works every time, never. So get rid of that guy. So here it is right here. The same thing already in a web browser for us, and it went ahead and built all of the JavaScript for us. Little bootstrap. Nobody's ever seen that before. Okay. So that's pretty interesting. So now let's do something even more different. So there's this library called ggplots, which basically allows you to create, ggplot2 allows you to create all kinds of different graphs and visualizations and things like that, and some maps and things like that. It also comes with, It also comes with a data set called MPG, which has a bunch of manufacturer or auto manufacturer information in there. So things about cars and stuff like that. So it's kind of an interesting little package, but I want to take you through a little bit of this code. And so all I'm going to do is from the UI side, I want to create 4 drop-down lists across the top that will filter data on a data table below. This is all the code that you have to write to do that. When we look at the actual server side, this is all the server code you have to write. So when it's rendering the data table, it takes that the MPG data, and based upon each of those drop-down inputs, we had this array back here that we talked about, right? We're passing in a hard-coded value for all, so we can handle the all, and the distinct list of manufacturers, because this data set is just a completely denormalized data set. It's a completely denormalized data set, very flat, so we just need to kind of create a distinct list of things. As the user selects all or the specific manufacturer or the number of cylinders or what type of transmission, those will be the 3 different drop-down types. It'll filter that back for us. So let's see that. So here it is. We have a data table down below. It has several records in here. It has the auto manufacturer, the model, displacement, year, number of cylinders, transmission, etc., whatever. As we select our manufacturer and maybe our cylinders, apparently Ford didn't have any in there. Okay. It will dynamically filter that data. So if you are trying to do some quick analysis and you built this little app in Shiny with all this code that you didn't write, you can create a great kind of analytics dashboard for somebody to use. Has a little search here too. If I type in Ford, for instance, it's dynamically searched. So the interesting thing about this is we actually built something very, very similar to this on our own using a couple different JavaScript framework libraries. And we spent a good bit of time and effort and money on building that. And because of comments and spaces, what do we have, 60 lines of code? We basically built a very similar thing. Now our app does a few more features and things like that, which I'm sure we can do in here as well. But the point being is, in no time you can deliver kind of robust analytics to users. And again, if I open up in the browser, it's just JavaScript right here. Same interactions. Pretty cool. Okay. Let me show you one more example. So let's say that we don't want to use SQL Server, but we still want to leverage R. Well, we can definitely do that. I did talk a lot about SQL Server, but that's because that's where I'm kind of partial to. But we talked about Shiny. We can take a data set in and leverage that. So that could have been from SQL Server or anything else. And let's show that how we can still have an MVC application and do the same thing. So I first want to show you this folder, this HTML folder, and it's blank right now, intentionally. And if I go into here and I grab some code and I run some code, and I'll explain a little bit here in a moment. What I'm really doing, get out of my way, is I am loading 2 libraries so I can create an ODBC connection and create an HTML file basically. And here's my ODBC connection. It's I created a connection or a DSN called NW. And here's, don't look at the password. I know you guys are zooming in on that. And then the rest of this is really just going to build the HTML file that we need to and drop it out to this folder. So now, when we go and look at that folder that we were just at, just kidding, we see this HTML file in there. So it dropped that HTML file in there that has everything we need to show the analytics back for this Northwinds database. In MVC, all we do is we just have a little view here that's calling an HTML helper class. That's really just building up our tables and everything. And when we run this, so now we've created MVC, and we're going to go grab that HTML file, which, if you're curious what that HTML file looks like, let's look at it. So it's just a very, very simple table. So what we could do is we could have a job that runs that creates this data table for us in HTML. It's all set up for us. And then MVC, let's stop this other one. In MVC, we can take and just write a little helper around it and show it back to us in a nice formatted way. We think we can. We can, okay. So this same data, that HTML file just being consumed here in MVC. Okay. So I did this talk because I felt like that R is becoming more and more mainstream. I mean, 10 years ago, if you said R, I don't think that most people would even know what we're talking about. I surely didn't. We hear it more and more, and we hear it because it's such a powerful platform, and more and more people hear. I don't know if even 10 years ago, if we asked who's using R, if we would have had even the half dozen hands that come up then. So I think it's something we need to think about, and just in the future, as we get more and more analysts and more data scientists using R and more of them into our environments, we are going to need to cater to what they're producing so we can show those to our executives and our other analysts and provide a conduit using the tools that we already know. So hopefully you learned something today. I apologize for some of the issues here. It's the nature of a live demo. So I hope you guys enjoy the movie, and if you have any questions or anything, come down and talk to me. Appreciate you coming out. Thanks.